Hello, I am Victor Netes from M2C. The topic of my presentation is the interval reliability, its usage and calculation for information and communication systems and networks. The huge role that information and communication systems and networks play in the modern world make it very important to ensure their dependability. Some aspects of this topic were discussed in my previous papers at the FRUCT conferences. This paper continues its consideration. Here you can see the outline of the presentation. Quality of service aspects related to different phases of service usage are depicted on the figure. The most important among is the service accessibility and service retainability. Service accessibility is the ability of a service to be obtained when requested by the user. Service retainability is the ability of a service once obtained to continue under given conditions for a requested duration. It is important to session-oriented services. A considerable factor affecting quality of service is the dependability. Availability primarily affects service accessibility, reliability affects service retainability. Dependability of an item is its ability to perform as and when required. It includes availability, reliability, and some other characteristics. Reliability of an item is its ability to perform as required without failure for a given time interval. Availability of an item is its ability to be in a state to perform as required. Well-known reliability measures are the mean operating time between failures and the failure rate. Important measure, called simply reliability, is the probability of performing as required for the time interval. The instantaneous point availability is the probability that an item is in a state to perform as required at a given instant. The most commonly used availability measure is steady-state availability, which is usually called merely availability. It is the limit of point availability when the time tends to infinity. The interval reliability is the probability that an item is in a state to perform as required at a given instant and, starting from this moment, continues to be in this state for a required time interval. It is at the junction of availability and reliability. The steady state or asymptotic interval reliability is mostly considered as for availability. The interval reliability is not included in the Terminology International Standard and is only briefly mentioned in IEC Standard on Mathematical Expressions. However, it is in the regional standards adopted for Commonwealth of Independent States. The interval reliability was considered in some well-known books. However, in some publications it has other names, interval availability or operational availability. Unfortunately, these names are already occupied, used in other meanings. This slide presents calculation of the interval reliability for an element. If and only if the distribution of operation time between values is exponential, then the interval reliability is the product of availability and reliability. For aging elements, there are the upper and lower bounds for the interval reliability. The difference between them is usually quite small, so they provide a good approximation. For series systems with independent elements, its interval reliability is the product of the corresponding values for all elements. For more complex systems, such simple calculations is not possible. For monotone or coherent systems with aging elements, the lower and upper bounds can be applied. However, for redundant systems, the failover time should be taken into account. If it interrupts service, redundancy increases availability but does not increase reliability. In this case, failover should be considered as a system failure. This slide and the next one present the proposed technique for interval reliability calculation in the case of interrupting failover. Let us consider a simple example of a network. Two scenarios are considered. Protection 1 plus 1. The protected connection has two disjoint paths. In this case, failover is not interrupting. And restoration, where all possible paths can be used for traffic transfer depending on the failure locations. The recovery in this case is not so fast, so failover is interrupting. This slide presents the main point of calculation for the case of restoration. The results of the calculations are in this table. You can see that in the second scenario of restoration, despite of use of a greater number of paths, the probability of an adverse event, which is a complement of the interval reliability to 1, is almost 15 times greater. And conclusions. The interval reliability is a useful dependability measure. It simultaneously takes into account availability and reliability, describing the impact of dependability on service accessibility and service reliability, retainability at once. Calculating the interval reliability for redundant systems, it's necessary to understand whether failover will interrupt the service or not. This has a significant impact on the service reliability. In this paper, a method of calculating the interval reliability in the situation of interrupting failover is proposed. Thank you.